Konnichiwa, minasan. Tashi no namahimawa taki sensei desu. Kyou wa sensei ni sasete kudasai. Yoroshiku onegaishimasu. That bit, right? At the start, that script. Hello, Sensei Muteki here. Gosh, I have a story around that. Before we start the actual calculus class for this evening. Man, contacting banks is a pain. No? Like anything bank related is a pain to do. I needed to contact my bank today for some bank related matters, and they put me on hold for like a full 10 minutes, maybe 15 minutes, I'm not sure. They put me on hold for like 10-15 minutes, right? I inputted all of my bank details, in response to the recorded instructions. You know how these things work, right? They'll give you a recorded set of instructions. Press 1, press 2, type your blah blah blah, type your this and that. So I did all of that, right? Type everything, all good, all great, right? Then the waiting began. Then the bank put me on 10 to 15 minutes on hold, right? And that wouldn't be much of a problem. You know how when operators put you on hold, they have this sort of like elevator music, or like what is it called? Like some sort of ad that'll be playing while you are on hold, right? Something pleasant, something that's it's meant to placate impatience, right? But this bank, you know what they gave to me? You know what they gave to me, chat? They gave to me this ad, right? They gave to me this ad that I think is meant to be more than 10 seconds long, but because for whatever reason, it stops exactly at 10 seconds. It loops all the way from the beginning after like, I don't know, maybe it is meant to be just a 10-second long ad. Maybe it was intended to be a 10-second long ad, but it didn't feel like that to me. Felt like it's missing a second half or something. It went along the lines of like what I said a while ago. Hello, Sensei Muteki here. Did you know that I've been with Muteki? Replace the details with the bank details, of course. I can't tell you the bank details, but hello, Sensei Muteki here. Did you know that I've been with Muteki for 20 years? Yes, they've proven to be the right university for me. I have my education, my future friends, and I've also planned out my VTuber career with them. And then immediately after that, right? Without skipping a beat, it just goes, hello, Sensei Muteki here, blah, 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 blah. And then it'll repeat again, hello, Sensei Muteki here, blah, 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 blah. And I was in that call for 10 minutes, 15 minutes. I was put on hold for that long. Hi, Diwa. Hello, Diwa. How are you? Let me give you a shout out. At Diwa Kuwak. There you go. But yeah, I was on that call. I was put on hold for 10 minutes. And then there's this ad. There's no music even. I don't think there was music for this ad. I think it was just a recording of someone saying, hello, something something here. Did you know that I have been with blah 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 for 20 years? I just kept repeating and repeating and repeating. It's a 10-second loop. And I've been in that call for what? 10 minutes? I've been on hold for 10 minutes? I swear. So every minute is 60 seconds. It's a 10-second ad. So every minute I hear it 6 times. I was in the call for what, 10 minutes almost, roundabouts. I must have heard that sickening, maddening script 60 freaking times. You know what's worse, right? Once I got into the call, finally, the operator picked up, right? I didn't want to go through the automated process because, for one, there's really no automated process for this. And two, I wanted to talk to someone to tell them my concern because I have a concern with the bank, right? They might be able to address the concern better if I gave them all the details. I think that's just natural, right? So the moment I got an operator to pick up on the opposite side of the call, right? This operator, to be fair, no issues with the customer service representative. All the customer service representatives I have talked to so far have been nothing but nice, right? They have always been professional, and while sometimes you get the hint that they have been working like 6 hours, 8 hours straight already, and so they're probably a little tired, but even then they still are professional, and I do appreciate them for that. But there were points during this call when the operator said, or the customer service representative, why am I unable to say that word? When the customer service representative put me again on hold because they were processing some things. And what's worse was they would put me off hold after a minute and a half, and then they will tell me, "Sir, we're still currently processing your request. I will put you on hold again for the next minute and a half." And then I will put on hold again for the next minute and a half. And guess what? Guess what? Throughout that minute and a half that was put on hold again, it's the same freaking ad. It's the same freaking script. I'm going crazy. I'm going crazy. Crazy? Crazy? I was crazy once. They locked me in a room. A rubber room filled with rats. Rats make me crazy. Crazy? It's same energy, right? Same energy. Like I feel like I'm listening to that crazy monologue again. Ren does that best. That crazy monologue. It has the same energy as when Ren goes through the crazy monologue. Oh my god. Oh my god. At least if Ren does it, it's adorable, right? This is just an ad. And see, will I be doxing if I share the name? Because the ad goes, "Hello, celebrity name here. Did you know that I have been with bank name for 20 years? Yes, they've proven to be the right partner for me. I have my blah 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 blah." If I say the celebrity's name, will that be doxing? Will I be doxing my bank? I'm not sure, but I have a feeling that it was not actually the celebrity that was voicing the ad, right? You know how sometimes, right? Sometimes the ad will introduce themselves as some sort of celebrity, like say Elvis here, something like that. Like they'll do an Elvis, but actually it's an Elvis impersonator doing the ad. I feel like it's that. I am not sure if the celebrity was actually the one reading the script. So like, and it's so grating. It's like, please get me out of this hell. Lesson learned: if you need something done with a bank and you need to do it via a call, I guess via in person too, it's same rules apply. But if you're gonna do bank stuff via call, give them like an hour. You have to have a full hour of free time. It's not going to end in 10 minutes. Because, you know, my naive brain was thinking, you know what? This is a quick request. I just need to supply the details of my issue, and then the bank will probably react to it, process it, do something with it, and then, yeah, call will be over and I can go about my merry way, right? 10 minutes, in, out, done, dusted. Nothing left to do, right? Oh, how wrong I was. Oh, how wrong I was. So yeah, how are your days so far, chat? How have your days been? How have your days been? Have you been alright? Have you been alright? Hope you didn't have to go through the same hell that I did a while ago this afternoon. So, if you've seen the thumbnail to this video, to this stream, wow, video. Oh, wow, are we doing YouTube videos now? Oh. If you've seen the thumbnail that I posted a while ago on Twitter, and if you've seen my announcements, if you're part of the Moteki server, then you would know that, and actually, I mean, the title of the stream says it all, right? Today, we are going to finally have that calculus class. It was one of our sub goals during the August Subathon, the 500 follower celebration Subathon, right? Major milestone for Sensay Moteki, and I guess for Moteki University as well. So this was one of our larger sub goals, and I have been both dreading and also eagerly awaiting this stream. I dread it because I know there's a stigma with math, and also I am not claiming that I am an expert in mathematics, but I'm also excited because I just love math. I don't know why. Math with an A, please. Math with an A, not with any other vowel. It's not moth. It's not myth. No, it's math with an A, okay? Unfortunately, math does not love me. So, So I'm not claiming that I'm a master at calculus. I'm probably not. Thank you, Iximir. Are you gonna be tuning in the stream? Oh my gosh, I will be called out for my mistakes. I'm gonna be making a lot of mistakes tonight. This is probably the limit. The limit. Ooh, calculus limit. This is probably the limit of my teaching prowess. At this time, it's going to be stretching, right? I'm stretching the limits of what I am able to do. Test the limits and break through. No right, no wrong, no rules for me. I'm free. I'm just gonna let it go. Just gonna let it go, and we'll just do this, right? We'll just do this. This is actually my first time encountering calculus. Oh, thank you for mentioning that, Diwa. So, we won't dive in directly headfirst into calculus. But we won't cover all the pre-calculus topics as well. Like if you follow any college level, maybe even high school level, senior high, junior high level calculus curriculum, you'll see that there are some pre-calculus topics like linear algebra, like what else is pre-calculus? Statistics? I think you take statistics as pre-calculus, right? It's mostly linear algebra. But we won't be covering all of that, but I would still be analytic geom. There we go. Anal geom. Analytical geometry, or sometimes you call it anal geom, but we avoid calling it anal geom because it sounds dirty. Stats din ng calculus? No, I think you can apply calculus concepts in concert with statistics. Kamusta po kayo, guro? Ito po, ako po ay mabuti. Kayo po sana ay mabuti din. Ginoong Shironiran. Ay, ginoo naman. Inassume ko naman. Sorry. Hope you're doing well, Shironiran. Anal geom and trig. Pre-cal 1, pre-cal 2 for your HSH. For your senior high. I see. I won't go into analytical geometry and trig. We won't be doing calculus on trig functions anyway. I don't think we will have time for that. This is just a 3-hour stream, guys. I have to compress a lot of things in 3 hours. But we will need to set the stage a little bit first. So I will probably start by talking about functions and equations, right? And then immediately after that, we'll go into linear functions, because linear functions and slopes are kinda important in understanding calculus. And then we'll go to a high-level definition of calculus, right? And then from there, we'll see how far we can go. I do not expect for us to cover derivative laws, for example. We won't be able to make it up until there. Like I said, we only have 3 hours, right? What I want you to have by the end of this 3 hours is a greater appreciation of this complicated topic. Every time someone hears the word calculus, they get put off and they get turned off and they don't want to go any further. People would always feel like that's their absolute limit. Haha, again, there's the limit pun. They would feel like, I draw the line at algebra. Any more than that, I can't do anymore. And it's sad because honestly, calculus is such beautiful mathematics. If you understand what's happening with calculus and if you understand what it's for and what it isn't for, right? It's the tools that it provides you is so useful, and the mathematics behind it is so beautiful as well, right? You know what they say? Mathematics builds on top of other mathematics. You start with the most basic. What's the most basic math that you would know? Arithmetic, perhaps? Arithmetic, addition, subtraction, multiplication, division, maybe. Even more basic than that, but ironically, it's taught at higher levels would be things like set theory, right? Set theory is actually the foundations, I believe, of like arithmetic and counting numbers. You start with set theory first. It's not set as in the character in League of Legends, although I don't know what theories about set can we come up with. That set and I don't know. Who do you ship with set? But anyway, you start with set theory, right? And then on top of that, actually there's even below set theory in this hierarchy of mathematics, you have Boolean math, I think is lower. It's about truths and operations with true and false values. Then on top of that, you build set theory. And then on top of that, you build your number theories. Your arithmetic is built on top of that. And then on top of arithmetic, you get your... I guess inside arithmetic, there's multiple also different levels. Then on top of arithmetic, you start adding letters. Right? You start adding letters in your math, and then you call that algebra. And then most of us stop at algebra. We don't get to appreciate, what happens if you want to do algebra on multiple numbers at the same time? So, linear algebra, matrices, and whatnot. And then we don't also get to see anymore, what happens if you want to do mathematics on things that are moving, on realistic things. See, the problem with algebra and arithmetic is, it's good enough to model our world as we live in it, right? Like, I can use arithmetic to calculate na all moving. Like, for example, right? We could use arithmetic to calculate, how much money will I earn by the end of the year? So you just take your salary per month, multiply it by 12, roundabouts, right? I'm sure there are other complications there, but for the most part, it's enough to give us this estimate of, how much money will we have at the end of the year, right? If we add a little bit more sophistication to that, we can probably start refining the estimate. We start adding variables. I usually spend this much in January, this much in February, this much on the other months. So now let's calculate how much money would I be projected to have by the end of the year. For the most part, algebra is enough for that, right? But that's not real. Every day, you have spendings. You spend a little bit of money here. You earn a little bit of money from there. And it's not at a constant rate. Your earning and your spending is not at a constant rate. It changes. Does that make sense? Your spendings and your earnings, they change day to day. If you want greater resolution, it changes hour to hour. Right? Might not be spending any money for the next hour, but if the hour after that I decide to browse Shopee or Lazada and buy something from there, then that's an increased rate of spending for me, right? For that hour, there's a spike in spending for that hour. And then the next hour, maybe I don't spend. And then maybe for the next 8 hours, I go to bed. But tomorrow, when I wake up, maybe I order coffee for delivery. So that's another spike in my spending. Maybe in the next hour, I order breakfast. So I'm maintaining my spending rate. And then after breakfast, for the next 3 hours, I won't spend. So there's a dip in my spending. What if at around the 5th hour of the day, I don't know, your friend tells you, oh, you know what? I owe you this much money. I'll pay you back. Oh, now you have a spike in your earnings. It's not it's an unexpected spike because you only think you'll earn like on the 15th or the 30th if you're working, you know. If you're a student, perhaps you earn through your parents' allowance for you. So it's at the start of every day. Right. But you get unexpected earnings and spendings throughout the day. Calculus allows us to factor in these changes in our earning, in our spending rate, and allows us to have better estimates at the end of the year of how much money we might have, how much savings we might have. And this is just for savings. There's so many things we do every day. Oh my gosh, I cannot wait for me to get a live 2D model. Hopefully there will be hand tracking. You can't see right now, but I'm like emoting with my hands. It's probably something that would be interesting to see once I finally get a live 2D model, and hopefully with hand tracking, like I said. You can see how animated Sensay becomes when I talk about these types of topics, these topics that I'm passionate about. So yeah. So my goal at the end of this 3-hour stream is to vary teacher behavior. Sorry, I mean, what can I say? Sensay online and Sensay in life. So it checks out, right? I also check papers, but it checks out. Does that make sense? Yes. Maybe it doesn't. I'm Sensay after all. Sometimes I don't make sense. I don't make Sensay. Anyway, most of the time what I say makes sense, but sometimes what I say don't make sense. I'm from Sensei Moteki to no Sensei Moteki. I don't know. Whatever. So, all I'm saying is, by the end of this 3 hours, my goal is for you to be less intimidated with calculus. I don't expect you to be masters of calculus by the end of the 3 hours. 3 hours is far too short, right? It's far too short. There's so many things we can do with calculus. But I want to open your mind, essentially, and open your heart as well. I know that this is not the easiest topic, but if I can make at least one of you appreciate the beauty behind this mathematics, then I would already be happy. This endeavor would have already been fruitful. All right? Are we ready? Now, I know my audience. I know that most of you are at least college level, perhaps. I don't think there's any junior high, senior high students in my chat. So, at minimum, I need you to know how to do algebra, right? At minimum, I just need you to know how to do algebra. Okay? Everything that we need to know calculus, starting from algebra, I will supply, and then we go into calculus. But at least algebra. Why not algebra? At the very least, right? You know algebra. You know what they say, algebra is math with letters. I have a friend, and I'm good friends with this person naman. I don't judge this person or anything like that, but I really don't like it when he goes, "Oh, I was doing okay with math until they added letters. When they added letters, ayoko na. I don't want to go on anymore when they added letters." And I'm like, "But the letters, those are what makes math so much more interesting. Now, no longer are we just solving equations, or not even equations, formulas with numbers, right? Now we're able to say, what if this is our missing value? We know how much in total we need. I just don't know the unit price, for example, of Let's say I'm buying 100 iPhones. I don't know. Why would you buy 100 iPhones? I don't know. Let's say you're buying like 100 iPhones. You know how much it will be. You know that you're buying 100, but you don't know how much each unit would be, right? Algebra allows you to do that. It gives you tools to do that. So yeah, algebra makes math interesting. So I hope you're not averse to algebra at the very least. All right. Okay. Let's approach the blackboard a little bit so we can start talking about calculus. Right. There you go. I cleaned the blackboard this time. It's nice and clean. Nothing there. Right? Let me test a few things first. I'm not gonna use a set of slides tonight. I could use a set of slides, but I think this being mathematics, I feel like it's better if I write stuff on the board on the fly. So, try first a few things. Let me know if my handwriting is legible. So, begin something very simple. A quick review of your algebra. This will be a little insulting to the intelligences of some of you, but it's fine. We start with something simple before we make things complicated. So, let's recall our algebra. And there's also a test if you can read my handwriting, right? Let's ask. Oh, that's a little too faint. Too faint. I want it to be more solid. There you go. X is equal to 3 plus 5. Can you read that? That legible? I'm also watching it on stream right now. Is that legible? That look okay? Move it around as well. Move it around. Let's see if be nicer if I put it here. There you go. Can you solve for x? What is x if x is equal to 3 plus 5? My handwriting's incredible. No, Diwa. I'm writing slow. If I'm not writing slowly, my handwriting will be abominable. It's more abominable than the snowman that appears in December. Right. So this one should be easy. This is more of just a test also for me to see how it would look like on stream. That looks nice. I can actually do this. I like this setup. You know what? If we're gonna have a part 2, if you want like another math topic, not calculus, please. Calculus is probably too difficult. If you want something else, we can have another lecture like this. It seems fun. Oh God, I'm having fun already. So, x here is equal to 8. Very simply, the reason is because you added 3 and 5, which yielded 8. Alright? We Gucci. This one is easy. Let's make it a little more complicated just to see if you remember your algebra. Let's do 8 minus x equals 5. 8 minus x equals 5. Solve for x. Ano po ang x? Ano ang x ninyo? What is the answer to x? Solve for x. Kaya ba? To solve for x, we need to apply the addition property of equality. Wow, ang bilis! Haha! Star student si Diwa. Very nice. Ang bilis. Actually, you can just do this logically. We know that 3 plus 5 is 8. So, what do you subtract from 8 to get 5? Right? Ganun lang naman siya. But if you want to do the mechanical way of doing this, so by the way, speaking of which, when I go through algebra later, I will go to calculus and calculus concepts later. I won't focus much on the mechanical aspect of the mathematics, right? Instead, I would put very strong emphasis on the intuition behind how the math works. And then I might present, because we need to at some point, right? We need to go through the rigors of mathematics. I'll present some of the laws, some of the rules, some of the mechanisms, some of the techniques. But my emphasis would be mostly on the intuition. All right? Okay. So, the intuition behind this is it says 8 minus x equals 5. What do I subtract from 8 in order to get 5? And from that, we can glean that the answer is 3. If you want the mechanical approach to do this, we can say, okay, let's subtract 8 from both sides. So we do negative 8 plus 8 minus x is equal to 5 minus 8. So subtracting 8 from both sides, right? Negative 8 plus 8 yields 0. So they cancel out, giving us negative x is equal to 5 minus 8 is negative 3. Right? But we don't want negative x. We want the value of x. So we will apply the multiplication property of equality. We can multiply both sides by negative 1. Right? Multiplying both sides by negative 1 gets rid of the negative signs, but retains the magnitude, retains the value. So we get x equal 3. Right? That works, no? That works. Simple, simple, easy, easy. All right. Good, good, good. Let's erase the board. Oh god, my eraser doesn't work. Why does my eraser not work? It work now? Orda? Why is my eraser like this? There you go. There we go. Erase the board. Erasing, erasing, erasing. Erasing, erasing. Realistic, no? Hindi nabubura ng buo. Parang totoong whiteboard, blackboard lang. Alright. Next. Let's try something else. Let's try something else. Ready? Ready? This one should be not too difficult still. But let's do y is equal to 5x plus 3. Let me move this a little bit. Being blocked by chat. Y is equal to 5x plus 3. Maybe I should hide chat for today, no? Should I hide chat for today? I should hide chat for today, so it's not blocking the black. Chat, sorry, it's not you, it's me. Actually, it's also not me. It's the lesson. It's the blackboard. I need to hide the blackboard. So, for today, chat won't be on screen. Okay? Just want to be able to use the entire black. Right. So, we have y is equal to 5x plus 3. What do we need if I want to solve for y? But what value do I need if I want to solve for y? Can I solve for y given y is equal to 5x plus 3? Can I solve for y? Can I solve for y? I don't think I can, right? I don't think I can. There's something missing. There's something missing. I need some value for x. I need to give a value for x. Let's say, if x is 2, can we solve for the value of y? If x is 2, let's solve for the value of y. That will be, therefore, then, y is equal to 5 times 2 plus 3, which gives us 10 plus 3, which gives us 13. So, if our x is 2, right, we get a value of 13. Right? So, what have we established here? I don't know if you noticed it, but we have established some sort of relationship. We have established some sort of mapping. Look at me fast forwarding through the concept of functions, right? We're sort of fast forwarding. So we can go into calculus in the next 20 minutes or so. So what we have done is we have essentially established a relationship between y and x, right? You have your x value, and then you have your y value, and we have established a relationship. If your x is 2, Your y is 13. If your x is 3, what will be the value of y? Can you calculate that? If your x is 3, what will be the value of y? That will be 5 times 3, which is 15, plus 3, which gives us 18. Right? So for every value of x, we have a corresponding value for y. Isn't that true? For every value of x, we have a corresponding value of y. So if we have a 3, the corresponding value is 18. If we have, what else can I use? How about 1.5? If x is 1.5, can we find a value for y? Can we find a value for y? So 1.5 times 5, that is 7.5, plus 3 gives us 10.5. So even if we're using decimal values, we still get a value for y for every value of x. Let's try something else. Let's try a fraction. Let's try 3 and 1/3. What's the value of y given 3 and 1/3? Hinahanap na naman natin si x. Ganun talaga. Oh, in this case though, we're looking for y given x. Kahit wala na siya. We're not finding x. We're not solving for x in this case at least. We're given an x. We have to solve for y. Ang bilis naman. 3.333. 3.333. Let's try. Let's try. So, we will replace x with 3 and 1/3. Right? Solve for y ito eh. Solve for y. Right? So, 5 times 3 and 1/3 plus 3. 3 and 1/3 is actually 10/3, right? This is also a test. Natatandaan niyo pa ba si fractions? I'm doing a side job while listening to Kafka, kurukurin on an hour loop. Wait, akala ko hinahanap yung decimal ng... No. The corresponding value for y. Yeah, I think I got where you got your 3.333. It is the decimal value for 3 and 1/3. Correct naman yun. Okay, so, tignan din natin if you still remember your fractions. You know how we got 10/3? 3 times 3 plus 1, right? You have 3 wholes. And then, each of these are divided into thirds. You need 3 complete wholes to represent this 3. And then you need 1/3 here. So how many thirds do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why 3 and 1/3 is equivalent to 10/3. Right? That's where it's coming from. That's the intuition behind the fraction. The mechanic simply is you're gonna multiply 3 by the denominator, the whole number, the mixed number with the denominator, and then add to the numerator. That gives you your 10. But the intuition is this. Okay? We get 10/3 plus 3. Now, we have to make 5 copies of 10/3. If we make 5 copies of 10/3, how many thirds will we get? So, 1 copy sees us having 10 1/3, right? 10 1/3. That's 1 copy. If we make 5 copies, it makes sense for us to have 50 1/3, right? I'm blocking the board now. I should move myself. Sensay, get out of the way. You're blocking the board. Move this out of the way. We have a sliding board today. We have high-tech sliding boards. Let us slide to the left. Right? So, is the intuition clear behind multiplication of fraction? We want to have 5 copies of 10/3. 10/3 means we have 10 pieces of 1/3. Think of it like pizza, right? Pizza that is cut into 3 slices. you have 10 of said slices, meaning we have 10 1/3. If you want to make 5 copies of that, then that'll be 50 1/3 or 50 over 3. Then we plus 3. How do we do this? If you add 3 to a fraction, you're adding 3 whole, 3 whole pizzas, for example. You're adding 3 whole pizzas. Since a whole pizza is composed of 3 1/3, and we're adding 3 whole pizzas, that's how we're going to get the 50 over 3 plus 9, right? Doon ang galing yan. I know that this is probably elementary to most of you. You've known this ever since grade 4, grade 5. This should be elementary to you. But I'm also trying to explain the intuition in case there are those who are not as familiar and they probably do not know the intuition behind fraction. You know, we've done studies on math learning in the past. And one of the first it is elementary. Yeah, fractions are elementary. Fractions are grade 5, grade 6, I think. But I won't blame you, Panda, if you did not learn this well enough. And if you abhorred this from elementary. See, from our studies, oh my god. Thank you for the raid, Azurine. Thank you for the raid, Azurine. How are you doing? Let me give you a quick count, Azurine. I shout you out correctly. There you go. Let's all follow Azurine. Thank you for the raid, Azurine. Oops, did I? Oh, now I'm following you. I'm gonna give you a follow. How was your stream today? What did you do? Before I explain what we're doing today. What did you do? No problem also. My pleasure to give you a shout out. Also, welcome readers. My name is Sensay Moteki, and let me be your sensei for today. Go take a seat and listen to teacher, okay? I'm good at rhyming. No, don't quote me on that. Project Diva. Oh, it's Tora who recommended me. Hello, Tora. Are you there, Tora? I'm not sure if you're part of the raid, Tora, but thank you, Tora. Thank you for recommending me. Thank you for remembering me. Played Project Diva. Oh. Project Diva is the rhythm game with Miku, right? There you are, Tora. There you are. Yeah. Okay. I'm gonna tell you something, Azurine. I think it's okay to tell this because I have done a stream on this, but speaking of Miku songs, we are planning on... I can't believe I'm saying this. We're planning on releasing a cover of one of Miku Hatsune's songs. If you're familiar with... How do you pronounce that? Sendrilon? Me and my friend Ren, we are going to do a cover of Sendrilon. I actually did a practice stream of Sendrilon several days ago. Well, actually, that was last week. One after dark stream. Thank you for the follow, Oshun. Thank you for the follow, Azurine. Glad you both could join the stream tonight. I don't know if I'm glad that you could both join the stream tonight because I don't want to subject you to what you might perceive of as hell. But in Moteki University, we do not think of mathematics as hell. We appreciate mathematics because we think mathematics is beautiful. It's just misunderstood. Oh my gosh, every time I get these sentiments of, oh, you know, I could have been good in mathematics, blah blah blah, but I hate this, I hate that, I hate it when they added letters, I hate it when they added a number on top of another number, right? Fractions. I feel sad, right? I feel sad not for the person, but I feel sad because this is how math is being taught at high school or elementary levels. Like, oh my gosh, believe me, even when I was growing up, when I was learning this for the first time, reminds me of my math club membership back in high school. Yeah, reminds me. Yeah. When I was growing up and I was learning math for the first time, if it wasn't for the really passionate teachers who took the time to explain the intuition behind what's happening. Oh, why is somebody in detention? Hold on. Somebody spawned in detention. Let me get you out of there. Sorry, Dandis. I did not mean for you to be in detention. No one needs to go to detention. Sorry for this, but honestly, I'm like that. So I'm enlightened how to properly understand math. Yun! That's all I want. That's all I want. All I want is for those who might not have had the best training or the best, learning to appreciate math more. Because it's a really beautiful concept. It allows us to understand the world we are living in a more precise way. Right? It allows us to understand the world we're living in a more precise way. So, for today, actually, the goal is to eventually make it to calculus, which is a really, really difficult form of mathematics. Now, I did say at the start of the stream, I do not expect everyone to be masters of calculus by the end of tonight's stream. All I want is for all of you to gain a degree of appreciation for calculus that might make you want to maybe in the future revisit and study it on your own. I had bad math experience kasi because the teachers prefer just giving papers. Okay, there is a point in that is supposed to be for practice, right? So the technique is dialed down. But to me, technique doesn't make sense if the intuition is not yet there. Intuition comes first, right? Once you know the intuition behind why you do certain things, right? The technique follows it. The reason why we have these techniques in the first place is because intuition says this is how things are supposed to be done. For example, we were discussing, let's go back to what we were discussing. Let me move this more to the left. We have a high-tech board, high-tech blackboard. We can move everything to the left. Okay, where were we? I need the equation again. So let me rewrite the equation. The equation we were working with is y equals 5x plus 3. Y equals 5x plus 3, right? And what we're trying to do is, actually I was trying to establish that by having this equation, we're essentially saying that there is now a relationship between y and x. So what we were doing was, all right, let's plug in some values and see this relationship unfold. So a while ago we had x and y. If x was 2, we said that y is 13. How did we get 13? So you replace x with 2, right? Then you perform the operation. 2 times 5 gets you 10, plus 3 gets you 13. So that's why you get a 13, right? And we can keep going. We don't just replace x with 2. We can replace it with any value that we want. If it was 3, we get an 18, right? If we use 1.5, I'll slow down a little bit for this, but the process is the same, right? The process is the same. We multiply 5 by 1.5. So we take an entire 5, that's the times 1. No problem, Tora. Thank you for the lurk. Thank you for dropping by as well. So you get your 5, right? And then I also need half of 5 because that's what 0.5 means, right? 0.5, the decimal, means I need half. So I need half of 5. Half of 5 is 2.5. I add 5 and 2.5. That gives me 5 times 1.5. That gives me 7.5. But I'm not yet done. We still have a plus 3. So 7.5 plus 3 gives us 10.5. Easy, right? Easy. So The intuition I'm trying to establish here is for every value of x that you could give to me, this equation, this formula will give me a corresponding value for y. We have now established a relationship between x and y. We can draw it like this. Let's say this is our space full of x numbers. This is our, what do we call this in math? This is our set of all numbers, for x. Then we have a set for all numbers for y as well. You can pick whichever number in this. Think of this as a bag, right? It's a bag full of numbers, and then y also has a bag full of numbers. You can take whichever number in x, you will be able to find a corresponding value in y, a mapping in y, right? I could take any value here, and I will be able to find a corresponding value for y. Does that make sense? This is what we establish when we make an equation like this. We establish a connection between x and y. Parang ano lang yan? What's a good analogy in life? When we make an equation like this, y is equal to 5x plus 3. Think of this equation. It's similar to friendship, right? Ang cheesy naman, friends. But yeah, every person in X has a friend in Y, right? Right? Every person located in this first set we call X will have a friend in the second set we call Y. That's what happens when we make this equation, right? We're establishing a relationship. In fact, if you allow me, I'm going to change the notation a little bit, right? You know how in math, they say, oh, I want to do things in terms of a variable. In this case, I want to eliminate the y variable by only using x. We'll change the notation a little bit, right? So, instead of saying y is equal to 5x plus 3, this is going to be a bit of a jump, but don't worry, for those who are unable to make the jump, I'll explain why it works this way, alright? Alright? But I'll make the jump first. Okay, I'll make the jump first and I'll come back for all of you to make sure that every one of you also makes the jump. Okay, are we good? So, I'm gonna write it this way. Fx equal 5x plus 3. So, I'm just rewriting our equation. We get rid of y. We replace y with f of x. So, I know this is a bit of a leap. But what does f of x mean? What does f of x mean? So actually, we can do it here as well. No? Tanggalin natin si y. Palitan natin siya ng f of x. So, ano ibig sabihin ng f of x? What does f of x mean? F is what we call a function. A function, you can think of it, the basic definition of it is a function is a relationship between the independent variable x and the dependent variable y, right? That's the math precise definition of a function. But for me, the easiest way to remember what a function is a function is a set of operations that you perform on a variable. If you perform these operations on this variable, it will give you an answer. Right? It will give you an answer. What variable are we gonna feed into this function? We're gonna feed x. We call this x a parameter. Parameter to the function. Right? This is just a very convenient mathematical way of writing the equation so that we can say, okay, what is f of 2, right? If f of x is equal to 5x plus 3. What is f of 2? What this is asking us to do is to take this 2 and replace all x's with 2 and then give me the answer. So, what is f of 2? Given f of x is 5x plus 3. What is f of 2? So again, replace the x with 2, then solve. 5 times 2, that's 10, plus 3, that's 13. That's f of 2. What is f of, let's say, 4? What's f of 4? We do the same thing again. We replace the x with 4, do the operation. 5 times 4 is 20, plus 3 is 23. So, we actually do still have the mapping. We are mapping x values to f of x. We still have this relationship. Every value in x connects to a value of f of x. Hello, Lil Ann. Hi, Lil Ann. Lil Ann. Hello. How are you doing? Yeah, it's math night tonight. It's one of our sub goals last August. One of the sub goals was a calculus class. So I'm just establishing a few prerequisite knowledge before we go into calculus, because if you don't know functions, calculus will make absolutely no sense. It will be like a jumble of letters and numbers and what's gonna happen. What? So I need to establish this first. Calculus, yeah. I just feel bad because the reason I added this to my sub goals is I feel bad that, calculus is so intimidating for a lot of people, but it's such beautiful mathematics. By the way, did you spawn inside detention? I think you spawned inside. Oh, Mikado spawned inside detention. Mikado, get out of there. You're writing articles. Ooh, articles for what? Articles for what, Lil Ann? Ooh, what articles are you writing? I'm interested. For school. Nice. You're part of the school paper. When I was a young boy, my daddy took me into the city. Sorry, broke into song. When I was still in high school, I used to be part of the school paper. I was part of the school paper. I was actually the literary editor of our school paper. So back then, I used to write and also critique literary works of other students. I got a bit of a reputation. There was a time when some of the students hated me because they would submit some literary works and I would recommend some revisions. That's part of the lit ed's work, right? The literary editor's work. But they took it the wrong way. I was just trying to make their work a little better. They took it the wrong way and they didn't want to resubmit anymore. So, I don't know. On the one hand, I feel like as lit ed, we want to make sure that the paper is as best as it could possibly be. But on the other hand as well, I also get why some people might not want to have their creative works critiqued. No? My editors are kind of intimidating. I think editors would be intimidating because whether or not you get published is in their hands. So, yeah. I tried to make sure that it's constructive criticism, but I was young, right? I was young. If I were to look back again at my comments on the literary work submitted to our school paper, I don't know. I tried my best to always be constructive, but I was young, so I wasn't a master yet. Thank you, Lil Ann. Right, so shall we continue? We now have. So by the way, Lil Ann, if feel free to hang out in tonight's class. It's gonna be math heavy, so again, maybe a small warning there. But at the same time, like I said, I will try my best to make it more intuitive rather than mechanical. There will be mechanical stuff. It's math after all, but I'll try my best to make it not as mechanical and more intuitive. All right? So, sit back, relax, take a seat, and listen to teacher. All right? But I'm so glad to have you here tonight, little Anne. I hope that you will be able to finish the article that you're writing for your school paper. All right. So, we now have an intuition for what a function is. We now have an intuition for what a function is. A function provides a relationship, a mapping between an x value and another value. A y value generally, but we can just call it the f of x. Okay? Now, this makes your x. Wow, what's up with my x? It makes your x independent. And then your y, your dependent. Or your f of x is your dependent value. In math, we have terms for this. The values of your x, we call that your domain. And the values of your y, we call that your range. The domain are possible values for x. And then your range are the possible value for y. Right? Possible value for x, possible value for y. Why does this matter? Why does this all matter? I'll give you another function, right? I'll give you another function and tell me if it's going to actually work, all right? If it's going to make sense. And credit where credit is due, I have to credit Iximir. I don't know if Iximir is still in chat, but I have to credit Iximir for this. I was reminded of this when I was preparing for the lesson plan for tonight. So, let's have another function. Have g of x is equal to x squared minus 4 all over x minus 2. Right? Oh, before you get intimidated. Oh my gosh, why is it g? I thought it was f. Why is it g? This reminds me of vertex form to general form. It's related to that, 100%. Because I believe vertex form, general form, those are linear functions, right? Those are linear equations. And, well, an equation could be expressed as a function. Yeah, so it's related. It's all connected. So, before I get intimidated, what is this? I thought we were doing f of x. Why is it g of x? What's happening? You can change the name of the function. Similar to how you could have variables called x, y, z, a, b, c. You can also have functions called f, g, h. You can use any letter that you want. In computer science, we actually use whole words, but for brevity, because in math, you're going to write a lot of these functions over and over and over and over and over. So for brevity, we could use single letters, like g, for example. In this case, our function is called g, right? Our function is called g, right? And when applied to parameter x, we call it g of x. So g of x. Let's determine int x equals to 1. And that's a variable. That's a programming variable. So, let's identify if g of x is actually a function. Let's see. We said a while ago that functions establish relationships between x and another variable y. From one variable to another, independent to dependent. Okay? We have an independent variable x and a dependent variable y. Pinag-isipan ko pa yan. That's a programming variable that you have there, Panda. Okay. So, we also claimed that every value of x in the x bag, right? Every value of x must be mapped to a value of y, right? There's one more in the definition. Each value of x must only map to one y. It's possible to have multiple x's. It's possible to have multiple x's. Parang si ano lang, no? Kind of like, what's his name? Scott Pilgrim with 9 x's. It's possible to have multiple x's map to the same y. That's fine, right? That's fine. It's okay. Hugot po ba ito? No, 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 no. just making light of the potentially heavy topic. This is how I teach in my actual work. I try to break up may matamaan. Oo nga eh. I try to break up heavy discussions with a sprinkling of jokes here and there, just to make sure that you're still with me and I haven't lost you yet in the sea of intimidating, confusing mathematics. So, it's possible for multiple x's to map to the same y, but we have to make sure that all x's map to a y. It's possible to have a y. Ixmir, correct me if I'm wrong. I think I'm correct here, right? I'm remembering this correctly. Ixmir is my resident math expert. If I need anything math related, I ask Ixmir. So, you can have a y that has no x mapping, but you cannot have an x without a y. All x's must map to a y. Multiple x's could map to the same y, right? But multiple y's cannot map to the same x. So this is not allowed. For example, I have here and I have two y's. It maps like this. Whoopsie. There you go. This is not allowed. That's not a function if that's the case. Okay? So given these properties, let us check if g of x is actually a proper function. Shall we? So let's list down some values of x, and then let's see if we can find a corresponding value for y. Let's try a very simple number. Let's try 0 first. If x is 0, what is y? If x is 0, what is y? So 0 squared, that's 0. The bottom denominator, that's also 0. What's 0 minus 4? That's negative 4. What's 0 minus 2? That's negative 2. This is negative 4 over negative 2, right? Negative 4 over negative 2 or 2. Tama ba? It's alright, Diwa. It's alright. No, no deductions for mistakes in my class. At least not when we're still discussing. That's one thing I also do not like about some classrooms. Admittedly, it's not the norm anymore, but it used to be the norm that when you're still in the process of learning something new, when students make mistakes, some punishment is levied against the student as if it's wrong to make a mistake. No! We make mistakes all the time in real life. The only thing that's encouraging is students being afraid to make mistakes, right? We mustn't punish mistakes. At least in what we call the formative phase of learning. Formative is when a new topic is being discussed, you don't know it yet, you're learning it for the first time. You should be allowed to make mistakes there because you could learn from mistakes, right? Sure, when we go to summative assessments, basically exams, since we have to have a basis for grades, that's how the educational system works nowadays. And yeah, you will get punished for making mistakes there. But it makes sense because an exam is meant to... What does the word exam mean? It's meant to be an examination of how much you know. So if you don't know, then you will make a mistake, and that's fine in the exam. When you get a 60 over 100 in an examination, because it weighs so heavily on students... Sorry, I'm on a tangent na naman, no? It's not math related. I hope it's okay. I hope it's okay that I'm venting my frustration. But if someone gets a 60 over 100, they feel sad, right? They feel sad because, oh, I'm gonna get a failing mark in my class. Oh, papagalitan ako ni mama, papaluin ako ni papa sa puwet. May ganun, di ba? And it's so wrong because an examination is meant to be a measure of what you know. It's meant to inform you. How much more do I need to know? But unfortunately, the way our educational system works nowadays, The way our educational system works nowadays, it doesn't work like that anymore. Oh, what's your question, little Anne? I was top section in high school and we're always expected to be correct. It's not how it works. So to expand this, right? I'll show you the solution. Don't worry. I'll show you the solution. That's also one more thing, no. If you have questions, um, I will take the time to answer, even if it derails the discussion. That's fine. I have to make sure that you're still with me somehow. So what happens here is we replace all x's with 0. So 0 squared minus 4 all over 0 minus 2. Right? 0 squared is 0 minus 4 all over 0 minus 2. 0 minus 4. It is. Not gonna lie, little Anne, a lot of the times when I do advanced calculations for, say for example, when I'm doing research, especially in things like, if I'm doing machine learning related stuff and there's like lots of math there, right? Most likely I'll make a mistake on the signs. I'll forget to cancel, etc., etc. Welcome to the class, Joseph Waffle VT. Glad you could join the stream tonight. Go take a seat and listen to teacher. Right, so 0 minus 4 is negative 4. 0 minus 2 is negative 2. The signs cancel each other out. And then 4 is divisible by 2, so they also sort of cancel each other out, giving us the final answer of 2. That's it. Stopping my writing to recall math. I'm glad that you're showing some interest in this class. I really am. It makes me happy when my student show interest in what I'm teaching them. Even if what I'm teaching them might be difficult at first or intimidating at first, all I really want is for my students to try. Right? If you're trying, then I'm already happy. If you're trying, I'm happy. If you're crying, then I'm sad. Please don't cry. We had the math class. It was chaotic. It depends if it's a good type of chaos. I love good chaos. Like if I have a class and it's chaotic because it's good chaos, everyone is like contributing. You're just copying the board. If it's because everyone's like contributing stuff to the discussion, I love those types of classes. It makes me tired. It drains me of energy, but it's also the best sort of feeling at the end. Yeah. So we try another value for x. But go ahead, please, Lil Anne, if you want to say. We had to find the vertex, the domain, the range. I see. That's for equations of a line. Yeah. Let's try something else for x. Let's try 1 for x. What's the value of y if x is 1? What's the value of y if x is 1? Finally, the most awaited calculus team. Hopefully, I get some redemption. We're not yet in the calc part, 13 draws, but we're gonna get there. Still have to talk about functions first because we need to understand what functions are before we could start talking about calculus. Right? X is 3. Shall we? X is 1. What's y? Actually, let's change this y because this is no longer y, right? We're using a different notation. This is supposed to be g of x. So if x is 0, g of x is 2. If x is 1, g of x is 3. Shall we test? So it's 1 squared minus 4 all over 1 minus 2. Alright. Okay. 1 minus 4 all over 1 minus 2, which gives us negative 3 over negative 1, which gives us 3. Very nice. Okay. It's 3. It's 3. Sana Earls. Sana Earls. Sige. Let's try one more. Let's try 3. Oh! Sensei, did you intentionally skip a number? Of course I did! Teachers do that all the time. You'll see why. If x is 3, what's g of x? If x is 3, what's g of x? So that's 3 squared minus 4 all over 3 minus 2. 3 squared is, what's 3 squared? 9 minus 4 all over 1, right? all over 1. 9 minus 4 is 5 over 1 or 5. What is 4? Last na ito before I show you the smoking gun. What is the g of x if x is 4? What's g of x if x is 4? Did I just scratch my microphone? Sorry, chat. Ito, last na. Okay, so 4 squared minus 4 all over 4 minus 2. 4 squared is 16. Minus 4 all over 4 minus 2 is 2. 16 minus 4 is 12 over 2, which gives us 6. So far, it seems like every value of x we can think of maps to one value of g of x, or maps to another value, right? Every value in our domain maps to a value in our range. Except for one. Except for one. Do you see it? Do you see it? Talking to you. Across the water, across the deep blue ocean, across the islands. No, no, no. No, 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 no. I don't remember the lyrics. Do you see it? Do you see the smoking gun? The number that I skipped. What number did I skip? 2? What is g of x given to? What is g of x given to? Are you sure? Are you sure? Oh God. Oh God. No, it's not 0. It's not 0, Diwa. Look. 2 squared minus 4 all over 2 minus 2. 2 squared is 4 minus 4. That's fine. That's 0. But 2 minus 2 is also 0. And anything divided by 0 is undefined. If it's 2, it's undefined. So that means g of x is not actually a function. Brain rotting only calamares. Oh no, you're brain rotting already? No, don't. Get back, Diwa. Get back, Diwa. Balik, get back here. So, there is a missing value, isn't there? We're missing a value. Yung kaluluwa ni Diwa. Hihilahin natin pabalik. No, I mean, ang sarap kasi ng calamares. I mean, if I'm eating calamares right now, I would also be distracted. Calamari is so good. Can I share a story before we proceed here? Sorry. Ang daming distraction. Sensay talaga. Pag nagdi-discuss, kaya ang tagal-tagal ng mga klase sensei eh. Parating may distraction. There's always a story to be told. Because that's the fun thing about attending a class, listening to stories. And it also gives your brain a moment of rest. Right? That means the earth is flat. No. The earth's not flat. The earth's not flat. That's not a proof that the earth is flat. Okay. What was the story? I forgot. Oh, it's about not calamari. It's about camaron. Are you familiar with camaron? Oh my God, camaron. I want camaron. I found out that one of my friends have never had camaron before. I'm like, what? And so, when was this? I think it was last Sunday or Saturday. We went out to a full proper Chinese restaurant just to have camaron rebusado. Oh my God, you have not had it yet, Diwa, camaron? If you think calamares is good, wait till you try camaron. Camaron is like calamares, but instead of squid, it's shrimp. It's shrimp. You might be wondering, so is it tempura then? It's not, because tempura uses a fluffier, airy batter. They use, I think they use a fluffier, airier type of batter. The batter of camaron is more dense. Not dense. It's still crispy, but it's denser than it's denser than tempura. Isn't it like a shrimp cuisine? Yeah, it is shrimp. It's if you're familiar with ebi fry, it's kind of like that. Tempura has thicker batter. Yeah, thicker. The batter is thicker, but it results in a fluffier, airier, crunchier external coating, right? Like a tempura would be like there would be like shattered flakes all over. And then that's the shrimp tail. A camaron would be more like it's more solid, right? It is very delicious though. It is. We had that last. I don't remember if it was Saturday or Sunday. I think it was Saturday. We had that last Saturday. Oh my god, camaron. Kind of want to have camaron now. Anyway, so let's go back. G of x is not a function if we declare that its domain is all numbers. We have to make an exception. And mathematics allows us to do that. We can say that for g of x to be a function, we must not include 2. We must not include 2 in the domain. Do not include 2, otherwise it won't be a function. Was confused. They said shrimps doesn't give anything to us really. Ah. It's kind of true. Shrimps are like the cockroaches of the ocean. Yeah. So the domain of g of x is all real numbers except 2. Right? All real numbers except 2. I think, if I remember correctly, see, this is also one of my weaknesses in math, notations. I have to do the research again. But it will be something like this. Let me erase this half of the board. Up. Said eraser, not talk. Eraser. It will be something like this. The domain of g of x. Nope. I need white. G of x, where x is element of all real numbers except. How do you write except? I forgot how except. Okay, erase yung board. Oh, of course I'll allow that. Bakit may ganun? Hey, Mod, why did you do that? Sorry, little Ann. That was not foul language. You said paki-erase. Man, my bot is too foul. My bot's too sensitive. Sorry, little Ann. But yeah, x element of all real numbers except. I don't remember how to write except. Okay, and we're allowed to do this. Math allows us to do this. So preserve the functionness of g of x. This will be important later. Okay, so are we good now with definitions of functions? It's okay. Sorry, little Ann. I did clear it, but apparently the bot is a little too trigger happy. The bot is a little too trigger happy. Just but you didn't do anything wrong. Don't worry. You didn't do anything wrong. Okay. So, are we good with function? Functions make sense? This is just a precursor to what we are actually going to discuss today. So now that we know what functions are, we can next talk about linear functions because this will be important later when we do some calculus-related matters. Okay? So, you're all familiar with the linear equation y is equal to mx plus b, right? You're all familiar with this. You've seen this before. We can just simply rewrite this as f of x is equal to mx plus b. But I want to tell you the intuition behind this function. It's a function now because we say f of x is equal to mx plus b. I know it gives PTSD to a lot of people, but I want to give you now the intuition behind this, right? So. if we have a linear function like this, it behaves just like any other function. We can give it a value for x. What you need to do is to substitute the x in the equation or in the formula with the value of x. So if we say f of 2, it means m times 2 plus b, right? Thank you for the follow, Little Ann. Glad you could join the stream tonight. Right, so that's what it is, right? But what causes PTSD, I think, is all of the slope intercept form, what else is there? This is the slope intercept form. What causes PTSD is when you start using this formula, things get a little hairy if you don't know what M is or what B is. Let me take this opportunity as well to show you that you can actually graph your functions. Ready for this? Ready for this? So let's graph mx plus b. So to graph, we will need x and y coordinates. We'll only deal with positive values for now to make things simple. But of course, we can do negative numbers as well later. Right? So usually, we put in the x-axis, the horizontal axis. Are we in graph? Yeah. Sorry, we're going to move a little quickly because you only have like 1.5 hours left and we haven't touched calculus yet. But I'll show you how functions are graphed, right? How do you graph a function? So your x-coordinate, your horizontal axis, usually is reserved for the independent variable x. And then your vertical axis is reserved for f of x if you're graphing a function, right? Okay. Let's have the most basic version of mx plus b. Lapit nang mag-time mo nga eh. Ang bilis ng oras, no? Time flies when you're having fun. Let's set m to 1 muna and let's set b to 0. This gives us a final f of x equals x. So how do we graph this? To graph this, we need our values again. If x is 0, what is f of x? If x is 0, what's f of x? If x is 0, sabi natin, f of x is just equal to x, so f of x must also be equal to 0, right? Tama ba? Are we all in agreement? If x is 0, and we say that f of x equals x, then f of x must also be 0. The mapping is very direct. The value of x is also f of x. Which means if x is 1, f of x is 1. If x is 2, f of x is 2. If x is 3, f of x is 3. So let's... x is equal na lang pala. Oh, yung x mo pala 0 lang eh. Hugot, grabe. So, let's graph. So, x is 0, f of x is also 0. If x is 1, oops, let me put this on another layer so I could reuse the graph. If x is 0, f of x is also 0. If x is 1, f of x is also 1. If x is 2, f of x is also 2. Right? So, if x is 0, 0 din siya. If x is 1, 1 din siya. If x is 2, 2 din siya. Right? We can keep going. If x is 3, f of x will be 3. We can keep going. Right? And if we connect all of these dots together, we form a line, a straight line. This is why we call mx plus b a linear function. It forms a straight line. Right? Right? Tama ba? But you might be saying, Sensei, Sensay, dami kong sinayang na graphing paper dati. Sensay, yeah, it will be a line kasi basic lang. f of x is equal to x. Sensay, paano kung hindi f of x equals x? Paano kung iba? Try natin. Let's say, let me erase this. I'm gonna use this. Laki ng aking eraser. My eraser is huge. Just need to erase a small bit at a time. Ayun. Oh, so paano naman kung what if our f of x is something else? Let's say, let's manipulate the value of m first. Let's observe what happened. Kanina, m was 1, right? That's why we had 1x plus 0. But the graphs do usually have negative numbers. Yeah. It will be down here. If you have negative, it will be down under here. -1, -1. And if you look at it, yeah. No problem, Diralan. Tama naman. You're correct. It's more of for simplicity's sake for now. That's why I was only looking at the positive numbers. But you're right. You are correct. Very much so. This graph extends to the negative. It doesn't stop at positives. It extends to the negative. Yeah? It does extend to the negative. It extends both directions. Very good intuition there, little Ann. Right. So, let's do this. Let's manipulate our m. Instead of 1, let's make it 2 instead. Ooh. Let's make it 2. So now we have 2x instead of just x. How did we end up at 2x? We set m to 2. So we replace m with 2. We replace m with 2. We set b to 0. So if you add anything to 0, it's a number itself. So it's essentially 2x plus 0. But that's the same as just 2x, right? Let's see the effect. If x is 0, what is f of x? Still 0. Right? If x is 1, what is f of x? F of x becomes 2. Does it not? Right, very good. If x is 2, f of x is panda. Tama naman, y is 2, but we'll call it f of x for now since we're dealing with functions na. It's just a different way of writing the same, right? So this becomes 4. If x is 3, f of x is 6, no? So if you try to graph this, notice what changes. No? So 0, 0 pa din. Pag 1, nasa 2 na siya. Pag 2, nasa 4 na siya. Right? Maybe over here. Right? Maybe over there, up there. If we connect this with a line, we form something like this. Oh? Right? So, can we observe something here already? What does our m control? If I increase the value of m, what does it control? If I increase m, doesn't it sort of rotate this line counterclockwise, right? It makes this line rotate. So it makes the line steeper and steeper and steeper, right? The higher this m is in the positive, the steeper this line becomes. That makes sense? This is why in math, m is referred to as your slope. Doon ang galing yung term na slope. Slope tells you how much are you rising versus how much are you running. So if your slope is 1, if your m is 1, this means you rise 1 for every run of 1. For every time you increase the value of x by 1, you increase the value of f of x by 1. Same yung rate ng increase. Same yung ratio. Your x, your f of x rises alongside x at equal rate. Right? Right? Pag umi-increase yung x mo, umi-increase din yung f of x mo by the same amount. If your slope is 2, that means your f of x increases by 2 for every x increase. So when x increases by 1, f of x increases by 2. We see that here, no? From 0 to 1, yung f of x natin nag-increase by 2. Right? So is the intuition of the slope clear? It's the steepness of the line. Yes, it is the steepness of the line. It is the steepness of the line. That's the m in mx plus b. That's why the term for m formally in math is the slope. The slopiness of the line. Does that make sense? Cool, no? When you understand the intuition behind the formula, it makes so much more sense versus just, your teacher gives you so many different formulas but hindi na explain what the intuition behind it is. But when you understand the intuition, it makes so much more sense. That's what m is controlling. So now, what does... Yeah. So now, what does the b control? What happens if we adjust b? Let's try. Let's do... Erase the board again. Let's reset our m. Isa lang. We're gonna manipulate only one variable at a time para hindi mahirap. Let's reset our m back to 1. And then let's set our b to 1. Kanina 0 siya. Let's make it 1 now. So f of x is equal to mx pa rin. No? So 1x plus 1. Keeping up with the Cartesians. Exactly. So, pag ganito na, let's calculate our f of x. At 0, if x is 0, what's our f of x? So 0 times 1, or 1 times 0 is 0, unfortunately, plus 1. So 1. If our x is 1, what's the value of f of x? So 1 times 1 plus 1. F of x becomes 2. And you can see the pattern, right? If x is 2, f of x will be 3. If x is 3, f of x will be 4. So if we plot this, let's get rid of this line because it's confusing. If we plot this, pag 0 yung x, we are actually at f of x is 1. Pag 1 yung x, our f of x is 2. Pag 2 yung x, our f of x is 3. Right? So that's our line. In relation to the basic f of x is equal to x line. So this is This is f of x equals x. In relation to this, our line is, ano itsura niya? It's like move to the left. It's sliding to the left. Pag isa lang x mo, function niya ay 2, tama. It's like the line has been slid 1 unit to the left. But let's pay attention to something here, no? If we set our b to 1, let's notice where this line, this purple line, is two-timer hala, is intersecting f of x. It's intersecting at 1. Right? Right? If our b is set to 1, our line will intersect f of x at 1. This is why the term for b is intercept. And this is also why, right, f of x is equal to mx plus b. This is why this equation is called the slope-intercept form. The m tells you how steep the line is. The b tells you where in the y-axis will your line intersect. Right? So that's the intuition behind a linear function. Okay tayo sa linear functions? Isn't it fun? Once you understand the intuition behind these formulas, it becomes a little easier to understand what's happening, no? And from here, you can make all sorts of fancy other formulas. Let me merge all of these kasi okay na. I can merge. You can move them to the left. You can start making all sorts of fancy different formula. Once I understand x doesn't have a value, I'm at peace. Yeah. The x value, well, I mean, sana wala nang value si x. Pero anyway, no. Let's not wish that upon other people. Ganok haba yung board? It's infinite. It's infinite. That's why I love this setup. It's infinite. I can make it as long as I want it to be. It's a mathematical impossibility, but the probability is this is infinity. Oh my gosh, nag battle rap bigla. Same brain cell moment. So this is how we come up with all of the different fancy formulas for tama, intuition. This is how we come up with all the fancy formulas for linear equations. So f of x is equal to mx plus b. If you think about it, we say that m is how much the line rises versus how much the line runs. So we can actually say that rises is changing in y over changing, and then runs is changing in x. So I'm not sure if you've seen this notation before, but don't be intimidated by triangles. Triangles talk about change. So delta in y, change in y, over delta x, change in x. So how much is y changing versus how much x is changing, right? So let's have an example for this, no? Say this is our line. Say this 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. Y squared minus y, and then the x2 minus x1. Yes! Yup! Gets na? Now is it making sense? Yung mga intercept, ano tawag dito? This is the vector form, vector intercept form, right? Vector intercept form. This formula, dun galing yun. So, for example, no? This is one point in the line. X, y. So 1, 2. This is another point in the line. 2, 4. This is another point in the line. 3, 6. Right? Right. Plus points each direct to the card. Tama. Hello niya kasi. Ordered pairs all coming back. Now it's all... Why are you in detention? me get you out. You're not. You're not in detention. No one is in detention right now. You yourself in detention. You're on the board sitting behind the detention box. If you are gonna be in detention, it's gonna be like this. Let's put Diwa in detention. Hey, let's put Diwa in detention, right? That's how it's gonna look like. The detention area is a hamster cage. Yup. So Diwa is now in detention. See? Keep me there. Okay, Diwa. I'll let you stay in detention. Solong-solo mo si detention. I found out how you could make like a box in Stream Elements or Stream Avatars. So I can keep people inside that box if I want to. The hamster wheel is unsafe. Is it? It probably is. Oh no. The pet expert niya kasen is here. But at least may tubig. Exactly. Of course, we have to provide for the people in detention. Free tubig, free water. Time check. Gabi na sa akin. Oh no! Oh no! Wala pa tayo sa calculus. It's already late. Alright. Tapusin natin to. Alright. So if we look at how... yeah, we're all in the same time zone. I believe we are. So if you look at how this line changes in Y, so nagsimula tayo sa 0, tapos nagiging 2, right? So nagsimula tayo sa 0, so this 0, 0, over here. Nagsimula tayo sa 0, tapos naging 2, tapos naging 4, tapos naging 6, right? 23 followers at 600. Wait, really? Oh, I didn't even notice. Oh my gosh. So, we're going from 0 to 2 to 4 to 6. What jalay, ma'am? Ako, what? So, this is a change that's about 2. This is also 2. This is also 2. So we are changing in Y by a rate of 2 each time, right? Let's look at the X. Starts at 0, then becomes 1, then becomes 2, then becomes 3. So the rate of change is 1 each time. So 2 over 1, which gives us a final slope value 2, right? And then for the B, let's just look at where it intercepts the y-axis. It intercepts at 0. So this means this line has the equation f of x is equal to 2x. Dun galing siya. Right? Then if you want to be precise about things, right? If you actually want the formula, delta y is the same as y2 minus y1. Delta x is the same as x2 minus x1. Is the slope positive? Yes. Because we are increasing pataas yung line natin. It's going up. That's another intuition. If the line is going up like this, expect a positive slope. If the line is going down the other way, then expect a negative slope. At least positive. Ay na! Yan, tapos na tayo sa linear functions. Tapos na rin tayo sa functions. We've also discussed what slopes are, right? And how we can relate slopes to change, right? A slope is a measure of how much our line is changing in y as it is changing in x, right? So that's what the slope is. Now, we can finally go to the main event of the evening. Calculus. Oh no, nakalimutan yung article. Sorry, little Anna, am I distracting you too much? So now we can go to calculus. Finally, we can go to calculus. Talk about oh, syempre, high-tech yung blackboard natin. It slides. It's infinite. It's never ending. It's a never-ending blackboard. There's a black hole eating the blackboard on the side, no? And then if I want to, I can reverse the black hole. It becomes a white hole and it spits out matter pabalik. Right? High-tech yan. Anyway, it's a supermassive black hole to the left of the blackboard. Anyway, calculus na. Green board. I never really figured that out. It's called a blackboard, but it's a green board. But there are actual blackboards that are black. Madumi nga lang sila tingnan. The blackboards accumulate dirt a little too quickly. I've worked with actual blackboards, right? The board is black. And if you use a white chalk, I don't calculus, I only calcuwin. Tama naman. I also calcuwin. Gutom ako. Pero ito na, calculus na. So now that we've covered all of the, what I would consider as bare minimum essentials for understanding calculus, we know functions, we know slopes in linear functions, we can start discussing calculus at a high level. Luto ako pansit sa gabi. Ooh, I want pansit. Oy, hello, Ren. You're just in time. We're about to talk about calculus. Ito na, calculus na. Parang gusto ko ng pansit canton. Gusto ko rin. Sarap ng pansit canton, no? Ito na. Calculus na. So, yung itlog pumutok. Oh! Actually, though, pag pumutok yung itlog sa pansit canton, oh my God, that's so good. My favorite kind of math is calculus. Alright. I hope I don't disappoint you, but we're not gonna go into super deep calculus tonight. Just high level. And then, if this is like something that you would like me to do again, we can have a part 2 and we can talk more about like the inner workings of calculus. So talk about this, right? Let's talk about this. Ready? What is calculus? At the highest level, high level definition, meaning not too much into detail. If algebra is the mathematics of static if algebra is static mathematics, calculus is a word, yes. Calculus is mathematics in motion. It's mathematics in motion. See, if I had a function, say f of x is equal to x squared plus 3, let's say I have this function, right? I can give it a value for x. Let's say f of 1 is equal to 4. F of 2 is equal to 7. For example, f of 3 is equal to 12. Tama ba? Right? I can do this, right? Every time I give it a value, it spits back out a number as well, another value, right? But it's static. Every time I invoke this function, every time I use this function, I get a value, right? I invoke the function, I pass a value, I get another value. Thank you for the hydrate, Mono AI. Thank you for the hydrate. Right? It's static. It's not moving. However, calculus is a step above algebra in that it introduces and it embraces the idea that values could change over time, right? And we see this in the 3 important tools in calculus. The 3 tools that calculus gives us. Limits. Oops, I need to use white for this. Limits, derivatives, and integral. Pwede mo na ako i-jail. My bad, kaka-sign out ko lang. Okay, you also want to be in detention? Right? Let me just put Chloe in detention. 10 na, wait lang po. Huwag patahin yung wifi. Oo nga pala, you are the warden of detention. Where are you? There you are. Oops. Warden of detention. Hindi kita mapulot. Join me, Chloe. Cage has 2. Now you're both in the cage. Right, so don't okay. I know PTSD, limits, derivatives, integrals, PTSD. Let me give you high level definitions of what this is. A limit talks about what value a function is approaching as x reaches a certain value. So, let me give you an example. Do you remember our g of x a while ago? G of x is equal to x squared minus 4 all over x minus 2. Do you remember this? Right? Sabi natin ito kanina, di ba? Oh, okay, little Anne. Alright, thank you for dropping by. I hope you learned something, even if it's not yet the calculus part. Thank you though for dropping by, little Anne. See you again soon. Bye-bye. Okay. So, g of x equal to x squared minus 4 all over x minus 2. We said a while ago that this does not have a value if x is 2. G of 2 is undefined. Right? Oh yeah, you have to work on your articles. Good luck on the articles, and I hope you'll be able to finish all of them. Kaya mo yan, I believe. Right? So, g of 2 is undefined, right? We established this a while ago. Try replacing the x with a 2. See what happened, right? 2 minus 2 yung denominator mo, right? Your denominator is 2 minus 2, which gives you 0. If your denominator is 0, then it's undefined, right? However, if we take a look at the graph for x squared minus 4 all over x minus 2. Wait, I have this ready. I prepared for you. Give me a second. Palitan ng dalawa yung okay. I prepared a graphing calculator for times like this. Okay? Sa inyo, I prepared. So, ilagay natin si x squared minus 4 all over muna tayo, x all over y. Replace ko tong taas. X squared minus 4 all over x minus 2. Okay? Kita ba? Hindi ko sure kung kita. Is that visible enough? Is that big enough? Do you see it? Do you see the green line? Do you see it? Talking to you. Across the water. So, let's zoom in on this graph. I want to show you something. Zoom in on the graph, right? Wait, kakabalik ko lang. What is this? Oh, so I'm graphing x squared minus 4 all over x minus 2. If you want to do this manually, pwede naman. You could try solving for different values for x. Mag-feed ka ng iba-ibang value for x. Your g of x will return values back to you. Put it on a graph and you'll be able to graph it. I'm just using a graphing calculator to make it a little easier so I don't have to do the manual step by step. Okay? Kdiwa. So, we're graphing x squared minus 4 all over x minus 2. Right? We're graphing x squared minus 4 all over x minus 2. This is the graph according to our graphing calculator. It looks like a line. And in fact, it is. However, akala ko ba sabi natin, if x is 2, this is undefined. Why is it a line? Actually, although it's not being shown by the graphing calculator, if you zoom in at x equals 2, can I zoom in there? Please. If I zoom in at x2, kita nyo ba yan? Kasi I don't know if it shows. If we could just get to x2. Yan. I'm gonna hold it in that position kasi if I move it even a slight bit, there will be a value. So at exactly 2, it's undefined in y. At exactly 2, f of x is undefined. Right? Undefined. But let's observe the behavior of the graph. As we are approaching 2, right? As we are approaching 2, look at the first number. The first number corresponds to x. The second number corresponds to f of x or to y, right? As x approaches 2, pampalapit tayo ng palapit, ng palapit, ng palapit, ng palapit, ng palapit to 2. How is our y reacting? How is our y reacting? Right? How is our y? Do you see it? Do you see it? Balik ko ulit ha. Start natin dito sa 1. We're gonna approach. Slowly, we're gonna approach 2. How is the y value reacting? It's increasing, right? It's increasing. But it's slowly approaching a value. Right? See? At x is 1.96, for example. If x is 1.96, y is 3.96. If x is 1.963, y is 3.963. If we approach even closer, x is 1.977, y is 3.977. We approach even closer. Lapit pa. 1.995, 3.995. Do you notice? Y is becoming closer and closer and closer to 4. But it never becomes 4. Because we know that once x becomes 2, y is undefined. Because your denominator is gonna be 0. But it does approach 4. Let's try tracing from the other side. Galing naman tayo from higher pababa. So as we go down the line, as we approach the value of 2 for x, notice what happens to y. Y starts at a large value, 4.7, and as we're approaching 2 for x, y also becomes less and less and less. It becomes closer and closer and closer and closer to 4. But it never becomes 4. At 2.03, y is 4.03. At 2.01, y is 4.01. It's closer and closer and closer to 4. But once you reach 2, specifically, exactly 2, it becomes undefined. The line has a gap. May butas yung line. At 2. Right? May butas yung line at 2. So, this process of approaching closer and closer and closer and closer and closer to a value of x and observing how the y is changing, right? And what value the y is approaching. This is what we call limit. This is what we call limit. We can say that, and I'll show you the notation as well, because the notation is a little intimidating at first. We can see that, right? The limit as x approaches 2 of x squared minus 4 all over x minus 2 is equal to, right? So there is a value for limit. It might be my stream quality settings, but I can't see the hole. Oh, the hole is so tiny. It's hard to see. It's really hard to see. Even in my, full resolution version, because hindi ko naman, I'm looking at it from my own screen. The hole is hard to see, but it's there. Right? So the limit as x approaches 2 of x squared minus 4 all over x minus 2 is 4. Another way to write this is the limit as x approaches 2 of g of x is equal to 4. That's limits. Limits tell you what number are you approaching as x approaches another number. What value is g of x approaching as x approaches another number? This is true whether or not the value becomes that, right? We know that g of x will never give a value of 4. It will never give a value of 4. The only possible way it could get a 4 is if x is 2. But if x is 2, the denominator is 0, meaning g of 2 is undefined, right? But if we observe the graph, g of x, as x slowly approaches 2, becomes closer and closer and closer to 4, but never reaches 4, unfortunately. So Chloe was asking kanina, is this related to the infinity thing? Sort of, yeah. Sort of. That's why in the graphic that you sent to me, meron dyan limit notation at some point eh. May limit notation dyan at some point. Does limits make sense? Anong point ng limit? Anong point ng limit? The point of limits is we're using change as a way to know an unknowable value. Isn't that amazing? Isn't that like fascinating to hear? We can never know what g of x is if x is 2, right? We can never know that. It's undefined. But we can approximate, we can estimate, we can know an unknowable if we allow ourselves to, instead of getting the exact value, we allow ourselves to just work with an approximation. What does g of x approach as x becomes closer and closer and closer to 2? But at the end of the day, it's just an estimation. Pati functions may limit din. Parang tao lang. Exactly. Exactly. Now, of course, this is an oversimplification of limit. There is more to learn about limits. And in fact, I could spend another session or 2 of this lesson stream for calculus. I could spend 6 hours, 9 hours, 12 hours more just discussing limits. There's so much to learn about limits. But the operational definition of it, right? The intuition behind it, what I would like you to take away, no, from this stream is limits is a way for us to estimate the value of a function as its independent variable approaches another value. I remember these lessons taking a week back in high school. Yeah, I don't think a week is enough even. Because you take maybe a week to build the intuition and then another week to practice the skill. Because it's still a skill at the end of the day. Now, herein also lies why we don't use limits often in real life, right? In real life, we don't really have situations where there's a gap in the data, there's an unknowable gap in our data. Like for example, if you're driving from point A to point B, right? You'll be able to drive from point A to point B. You'll know your location, right? How far you are from point A. If you are at point A, and you're driving to get to point B, any point in time, you'll know your location by checking the distance between point A and your current location, right? That's easy to find. You don't often encounter cases where you'll be lost, for example, if you end up at this point. We don't often encounter real situations like this, no? That's why we don't really deal with limits all too often. But in mathematics, we encounter cases like this all the time. A value seems to approach another value. It becomes closer and closer and closer but never really reaches that value. May puno dun sa x equals 2. Siguro nga, no? Siguro nga dito sa distance of 2, may puno. Kaya hindi mo alam. I suppose that works. Pero yeah, we don't often encounter this in real life eh. At least if we're not dealing with mathematical applications then. However, designers, architects, graphic artists might encounter cases like this. Right? Iniwasan ng engineer. For example, let's say you have a square. You cut it in half. You cut this in half. So this is 1/2 of the square. Cut it in half again. This is 1/4. Cut it in half again. This is 1/8. Cut it in half again. This is 1/16. Cut it in half again. This is 1/32. So forth and so on, right? You keep cutting in half. Cutting in half. And then you try to get the total of all of these. No? So it's 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. I don't know if you'll ever encounter this in real life. But if you try to add all of these in a series, you'll find that it approaches a certain value. As the denominator is a power of 2, no? So this is actually 1 over 2 raised to 1. And then this is 1 over 2 squared. This is 1 over 2 to the third. This is 1 over 2 to the fourth, etc., etc. So if we call the power as, let's say, x, right? This is our x. And then let's say the sum of all of this as x approaches, let's say, infinity, right? Pataas ang pataas to eh. This is x is 1, this x is 2, x is 3, x is 4. This could go on and on and on until x is infinity. What is the sum of all of these fractions? We can say that it approaches, actually for this one, it approaches, if I remember correctly, it approaches 2. Because this is length 1, this is length 1. It approaches 2, but it never makes it to 2. It never makes it to 2 because you keep cutting in half. You keep cutting in half until at the very, very tiniest atoms, until at the very, very tiniest quarks, right? Super, super tiny, you still cut in half, cut in half, cut in half, cut in half. It will never be equal to 2, but it approaches 2 as more and more of these fractions gets added up together. Ang daming x's nga eh. When in doubt, DNE. Okay? So yan ang limits. Limits allow you, I'll make it kind of dramatic because this is how I think of limit. Limits allow us to know an unknowable. We approach a value. We may never know what that value is, but we could guess. It gives us a way to know the unknowable. So, mga undefined na function, we could use limits to know what its value is once we reach a value of x that gives it an undefined result. That's the beauty of limit. Okay? Shall we take a short break at this point? Baka overloaded na kayo with you're at your limit na din, no? Baka at your limit na rin. May derivatives pa tayo in integrals. May derivatives pa tayo in integral. Maybe you're already at your limit. So, do we take a short break? I'm actually hungry. I've been looking at the table filled with food. I kind of want to eat too. Let's try it. Sensay is taking a short break. Let's take a short break, everyone. Around 5 minutes. Fun fact, nagtaka mga profs at kaklase ko dahil nagkakalculus ako sa library, wala namang calc sa psych. Walang calc sa psych if you don't try hard enough. There is calculus everywhere. For as long as there are numbers that change over time, for as long as there are values that evolve and transform over time, and that transformation is mappable using a function, right? There will be calculus. There will be calculus because we have to find a way to describe For example, limits. Where does it approach? What value does it approach? Derivatives. How is it changing? Integrals. To be fair, integrals is more specialized, but what's the area under the graph? It's really more specialized. I did not read too much into integrals because I didn't think we'll make it to integrals. But hey, if there's interest in this, sure, why not? I'll review my integrals and I'll teach it to you as well. But yeah, for as long as there are numbers that change over time and you want to describe how this change is happening, there will always be calculus. So I don't know if there are cases like this in psych. I don't know if there's like quantification that happens in psych a lot of the times. Maybe in, I don't know, surveys or something like that, there could be some form of quantification. Because that's happening. There are numbers, and these numbers change over time. Calculus could be used to describe how it's changing. I'll take a short break. I just need to refill my water and take a piss. As one Mr. Halsonaros would always say, need to empty the dragon. Whatever that. I leave, that's more on statistics though. That's why we have stats. Oh. I leave Nyakasen in charge of the class. Nyakasen, please watch over the class. Sawayin mo po yung mga Pokemon na makakulit. Hey, I have returned. Sinong na-stuck? Who's stuck? Who's stuck? Who's stuck? Who's stuck? I am stuck? Where? Oh nga, why are you there? Tama kayo dyan sa loob ng detention. Ayan. Ayame is no longer stuck. Ayan, okay na. Unstuck. Ayan, magsama kayo ni Chloe sa loob ng detention. Nawala na si Diwa. Umalis na si Diwa sa detention. Iniwan na niya kayo. Diwa is no longer in detention. Magsama kayo dyan. Talaga tong dalawang to. Okay. May energy pa ba kayo? Nisip ko kasi, sige, the last thing we will discuss tonight, because I think we may have overloaded ourselves already. We've talked about functions, linear functions. We've talked about high-level limits, like high-level discussion of what limits are. Medyo nakaka-overwhelm talaga siya. So why don't we end with a high-level definition of derivatives, and then we'll schedule a part 2. Kasi puro pa tayo definition, wala pa tayo example man lang. We'll schedule a part 2. What do you think? Does that sound good? We could just schedule a part 2. Gawa na lang tayo ng part 2. If I keep going kasi baka wala nang maintindihan because we're already quite mentally drained. We'll schedule a part 2 na lang. Let's continue muna. So, this to the side did say that limit we mentally drained na ako, but not because of the class. I understand, Chloe. I understand. So limits allow us to know the unknowable by observing what value our function approaches as its independent variable. Approaches a value. For example, limit of g of x as x approaches, let's say, 0. As x becomes closer and closer to 0, what does g of x become? What does it trend toward? Maybe g of x has a value if x is 0. Pwede naman yun. Let's say g of x is equal to x. Ano ba? Anong maganda? X squared plus 1, right? There's a value for g of x at 0. So if g is 0, we know that this is 1, right? We know that this is 1. So as x approaches 0, habang palapit tayo ng palapit sa 0, we can expect the value of g of x to become closer and closer to 1. So like this. If our x is, let's say, 1, our g of x becomes 2. Sorry, dito dapat 5. Dapat g of x. Para mas madali intindihin. So if x is 1, g of x is 2. If x is 0.5, what's 0.5 squared plus 1? 0.5 squared plus 1. That's 1.25, no? 1.25. This is 0.25. 0.25 squared is 0.0625 plus 1. 1.0625. If this is 0.09, palapit tayo ng palapit sa 0. Times 0.09 plus 1. This is 1.0081. Right? And if we become closer and closer and closer to 0, tuloy natin dito. If it's 0.009, for example, palapit sa 0, we get 1.0081. Right? Got me some piyaya. Wow, piyaya. Sarap naman. And 0.0001 9. Ganun din, palapit tayo ng palapit sa 1. 0.0, I believe this is gonna be 0.00000081. Right? Palapit sa 1. This value becomes closer and closer to 1. Right? Because the limit as g of x approaches 0 is 1. That's the calculated limit that we got. Right? And in fact, if g of x, if we set x to 0, if we get g of 0, tama, makukuha naman talaga natin si 1. Pero yun nga, some functions aren't like this. Some functions, kapag naabot mo yung limit value, magiging undefined siya somehow. Right? Like, for example, if we change this to x squared plus 1 all over x, for example, as x approaches 0, when x is 0, this is undefined. But we can still see what the value of the function is trending towards habang palapit si x sa 0. Alright? So, tayo kay limits. Now, in part 2, if we have a part 2, I can tell you how to calculate for limits. We have limit laws kasi. Pwede ko rin ituro yun ngayon. Kaya nyo pa ba? Do you want to know the limit laws? How do we calculate for the limits of functions? Marami-rami din yun. Pero hindi naman sila ganun kahirap. But if drained na, I'll instead go to high-level derivative. I'll go to high-level definition of derivatives instead. Tapos mag-schedule tayo ng part 2 for calculus. Part 2 ng calculus. Okay? Sige. What do you want, chat? Do you want to proceed with limit laws? Na baka the danger is, here's what I'm thinking, no? I can sense that you're probably kind of tired already. If I discuss limit laws now, it's not gonna be any different from when you discussed calculus for the first time. It's going to not make sense again. So instead, let's go do a high-level definition of derivatives instead. High-level derivative. For derivative, I want to start by drawing a graph again. Let's draw a graph again. A nice little graph. And let's say the graph of our function. Thank you for the follow, Chips Noraj21. Glad you could join the stream tonight. Go take a seat and listen to teacher. We're talking about high-level calculus tonight. I was supposed to discuss more. Who agrees on the fact that what is this? What is this? There you go. Thank you. Very, very quick. Very, very quickly handled. Thank you very much. Man is unclothed. Yep. Nothing happened. Same. Honestly, same. Let's not even go there. It's not. No. I do not agree. Gosh, I am controlling myself from going on a long ass tirade. We have something that we need to discuss, alright? My gulay. Anyway. Because it makes me mad every time I see that sort of argument transpire, right? And then people would say, oh, physically ganito, ganyan. No! Oh my God, kung discuss mo yan, which I know you won't. Open na thoughts, so marami akong masasabi. No, maybe not in detail. All I'm gonna say now is, I hate that topic so much because it puts aside, it denies the fact that humans are multidimensional beings, that it's not fair to classify people just because of their genders or whatever, right? Yun lang. Ganun muna. Otherwise, we'll be here forever. So, Chips, tips. I think I need to thank you for bringing that topic up so that I could share my point of view from that. But we do not tolerate those types of discussions here. Okay. Let's just talk about derivatives, all right? So for derivatives, let's draw a graph first. Have a graph that looks like this. I do not know if this is f of x. I am not sure the actual formula for this, but there is a formula for this sort. This might be something related to sine because this looks like a sine wave. Okay, so let's just use this. Now, let's say I want to know, let's say this is x is 1. This is x is, let's say, 7. Let's just say, right? So I want to know how, this is our f of x, no? This is our x. I want to know how much on average f of x has changed between 1 and 7. I want to know how much f of x has changed between 1 and 7. So in this span, from 1 to 7, how much has f of x changed? We see, notice, pay attention. We see that after 1, f of x increased, right? It increased. But it reaches a crest and then it starts falling again. All the way until we reach 7. So there is a bit of an increase, quite a bit of an increase, but there's a lot more decrease, right? There's a lot more decrease. So on average, how much has the line changed? Or how much has the function changed? We can get this average, fascinatingly enough, by drawing a line that connects f at 1 and f at 7, right? And here's what's interesting about this line. This line, let's call this g of x, will have a slope. It will have a slope, right? This slope tells us the average rate of change. Tells us the average rate of change of f of x, right? Between 1 and 7. This slope tells us the average rate of change of f of x between 1 and 7. So why is this important? Wala pa tayo sa derivatives, ha. This is just heading towards derivatives. But why is this important? Think of it this way. Maybe, let's say, this graph represents a car as it is traveling over a road, right? 1 here represents to the first second, or let's say first hour, para naman medyo realistic. This is the first hour of travel, and then this 7 is the 7th hour of travel. Let's say f of x represents the speed of the car, right? So what does this graph mean? At the first hour mark, it seems like our car is accelerating. It's increasing in speed, right? It's increasing in speed. And then at some point, it starts decreasing in speed until it plateaus and maintains the speed. And then afterwards, it'll increase again, but we're not interested. Only interested in how the speed is at time 7 and how the speed was at time 1, right? This line tells us on average that our car actually slowed down. Even though there was this slight increase in speed, look at the rest of the travel, we were decreasing in speed. So on average, the car was actually slowing down, right? On average, between 1 and 7, the car was slowing down, right? Now, if we change this interval, let's say from 7 to, let's say, 9, right? If we do the same analysis, we draw a line connecting f of 7 and then f of 9, we see that the car was speeding up, right? The car is speeding up. So between certain intervals, even though there are slight increases and slight decreases, in total, on average, certain intervals will have the car decrease in speed. Certain intervals will have the car increase in speed. Right? Right. Does that make sense? And this is identified by the slope of the line that connects f at x sub 2 and f at x sub 1. Right? The slope of this line tells you the average rate of change. On average, over that interval, how much is the car, in this case, changing in speed? How much is the car changing in speed? The slope tells you that. And this is such a powerful tool to have in our arsenal because, let's say, for example, somewhat timely. It's League of Legends World season right now, right? It's Worlds 2023 season. So whenever teams play a game of League of Legends, you could look at the gold graph, the gold differential, right? Legends never die. Yes. So you can see how, for example, gold favors one side. For example, the blue team over the purple team at some points. And at some points of the game, the gold favors purple team over blue team. So if you want to know who is in the lead or who is on average, or on which side on average is the game trending towards between, let's say, minute 10 to minute 20 of the game, you could apply the same analysis, right? You could apply the same analysis. You could see which team the game is currently favoring in terms of gold differential. See? But the graph of gold differential, the graph of gold differential actually looks erratic, right? So let's say this is gold, right? And then this is the team. So this is blue, this is purple team. The gold differential graph might favor blue team first, and then all of a sudden it favors purple and then blue, and then it stays here for a while, and then it favors purple again, blue, and then eventually maging ganyan, right? Let's say. Sorry. This is not gold. This is gold. Y-axis is gold different. This is time. So over time, right, if it's on top of the x-axis, then that means it favors, let's say, blue team. So blue team is ahead. If it's above the x-axis, blue team is ahead. If it's below the x-axis, purple team is ahead. But by how much, right? Let's say, ganyan siya. So let's say at the 10-minute mark, between the 10-minute mark and let's say the 20-minute mark, where is this graph trending toward? So we plot what is the gold diff at time 10. So gold diff at time 10. Then we take gold diff at time 20. We connect that with a line. Ang pangit ng line ko. Hold on. Let me connect that properly. We connect that with a line. And we can see that from the 10 to 20-minute mark, it seems like blue team or the goal differential is trending more towards blue team, right? It's trending more towards blue team. Blue team, if this graph continues to behave in this way, blue team will be on the lead, right? right? Does that make sense? Does that make sense? If we're only observing from 10 to 20, of course, if we change the interval, let's say we observe from 10 to, let's say, 30, it tells a different story because goal differential at 30 is now showing that purple side is winning. Okay, purple side is gaining more gold. But, yun. At certain durations, we can see kasi what the average rate of change is. Right? And then use that to determine who might be winning from that time to another time. From time 1 to time 2. Right? So, how does this all relate to derivative? How does this all relate to derivative? Let me redraw this graph because it's already quite messy. Redraw the graph. Right? This is our f of x. This is our x. Right? Okay. So, the wider the gap between the intervals, let's say this is 1, this is 6. The wider the gap between the intervals, the more tends to happen to the graph. Like we see increases, decreases. And while the line that will connect the values of f of 1 and the value at f of 6, while the line that will connect that still tells us the average rate of change, right? Yeah, I mean, it's only useful if you're looking at from 1 to 6. We can lessen this interval. We can make it smaller and smaller. 5, 4, 3, 2. We can make it smaller and smaller. And then the smaller the interval becomes, the tighter the line becomes, if that makes sense. Right? The smaller this line is, the smaller this interval is, the more predictive almost the line becomes. Right? So parang mas siya, it becomes more and more indicative of a certain moment in time. Because sometimes we're not interested in an interval like from 1 to 6. We're not interested in the rate of change from 1 to 6. I'm only interested in one moment in time. Give me one moment in time when I'm racing with destiny. Kunyari lang, right? Kunyari marunong kumanta. So, sometimes, we're not interested in the rate of change over an interval. Instead, we're interested in the rate of change in one instant, in one moment, right? What might the line be? Let's erase all of this. What might the line be at not an interval, but only a single point? What might this line look like if we only have one single point? Right? And I know it sounds strange. Like, how are you going to find the rate of change if you only have 1 point? You need 2 points. You need the starting point and then the ending point, so you could get the rate of change in between those points. How are you going to get it on one instance? This is where derivative come in. Right? This is where derivatives come in. The slope of this line is the instantaneous rate of change at x equals 1. Meaning, at that one moment in time where x is 1, where is the graph trending? Where is the graph going? Is it increasing? Is it decreasing? How much is it increasing? How much is it decreasing? That, my friends, is derivative. That is where the derivative of the graph of the function at one point comes in. Now, this is something that is not as, I don't know if this is taught in college calculus. I think sometimes you skip this derivative at a point because the next level to this is, what if I don't want to calculate the slope at every single point? Can I find a formula that if you give me an f of x graph, if you give me this pink f of x, I will be able to get a formula that, let's call that f prime x. That if I give a value for x, it will give me not the value of f of x at that point in time. Instead, it gives me the instantaneous rate of change, right? At that point in time. I don't want the value of the function at x. I want to know, is the function increasing or decreasing, by how much or by how little at that point in time in x. This is what you classically know as, for those of you who have taken calculus before, this is what you classically know as the derivative of f of x, the derivative of the function. But you're not limited to getting the derivative of a full function. You could get the derivative of a function at a single point if that's the only data that matters to you, right? Right? This is useful, for example, in, let's say you have a business, right? You have a business and you plot in a chart, how much money are you making? How much is your income per month? January, February, March, April, May. And then you'll notice that it seems like on certain months, your income is increasing, but on certain duration of months, your income is decreasing. You could use derivatives to know in which month specifically is your money increasing or income increasing, and which month specifically is your income decreasing, right? You'll notice kasi, if for example, this 1 corresponds to January, this 6 corresponds to January, February, March, April, May, June. This corresponds to June, right? And then all the numbers in between corresponds to different other months. You'll notice that sometimes you see that your income is increasing, but there are times when you are in the negative, right? So you notice that you're increasing and decreasing each time, but you want to know, in January, am I increasing? By how much? In February, where am I trending? Am I trending towards increasing or am I decreasing already? In June, where am I trending? Am I trending towards increasing or decreasing? By how much? Right? Derivatives allow you to estimate, allow you to approximate these. Kaya sabi ko kaya I really see the beauty behind calculus. It allows you, so if limits allow you to know the unknowable as values approach other values, derivatives allow you to know the unknowable if the unknowable is my function increasing or decreasing? By how much or by how little? And this has so many applications in modern day, right? There's so many applications. We don't use it directly very often because we can just estimate. We could just look at graphs, for example, and we could know. But if we're curious to find out the nitty-gritty details, derivatives is what we will need. Okay? So, we are almost at the 3-hour mark. I suppose we could end here. I could sense that quite a lot of us are already tired. So, we can end here. If you want to have a part 2, let me know. I'm open to having a part 2 of this. I'm also open to having a part 2 of the game design class. There's so much more we could also talk about game design. In fact, if you think that you learn quite a bit from my streams, I'm taking suggestions for topics as well of what we might discuss next. For now, let's go back to the classroom, hang out for a bit before we go and raid out. I hope you had fun in today's calculus class. I know it's a really complicated topic. I mean, I tried my hardest to prepare as well as I could to break down the complicated topics involved in calculus. It's an ambitious undertaking for us to have like 1 3-hour calculus class, but I did my best. I hope that what we set out to do from the very beginning, uh, having you gain a greater appreciation of calculus was achieved somehow. No? All right. So I suppose it's time that we raided out. I will dismiss you now. Let's look for someone to raid. Who should we raid? Do you have... I want to raid someone we have not raided before. There's so many people streaming tonight. Yo! Did we raid Kirarin? But we've raided Kirarin before. Who do we raid? Who have we not raided in a while? Chat, do you have suggestions for who we can raid? Who have we not raided ever? Rena Fenrir. Rena Fenrir is playing Goose Goose Duck. Goose Goose Duck. I don't think we've ever raided Rena Fenrir. So, hey, if you want to watch... Oh, they're doing a collab. Ooh. They're collabing with... Oh, they're collabing with a lot of different people. Let's raid Rena Fenrir. Yeah? Let's raid Rena Fenrir. I am Rena, a wolf that's on a journey of self-discovery and unraveling the mysteries. Oh, let's go raid Rena. Go follow Rena. Go show our usual support for the channels of our friends, right? I trust that my dear star students would be civil and will be respectful of the people we are raiding. No? Can I trust that you will be? Can I trust that you will be respectful? Chat. Can I? Well, else next time you'd all be in detention. Sige kayo. Our raid message tonight will be... Do we do calculus raid? Limit raid? Calculus raid. Calculus raid. It will be our raid message for this calculus raid. Can't think of any other raid message, so we'll just use calculus raid. Yeah? Calculus raid. Then, yeah. What else am I forgetting? Tomorrow we'll be streaming again. What did I schedule for tomorrow? Yu-Gi-Oh! We'll be streaming Yu-Gi-Oh! Tomorrow. If you have missed me playing Yu-Gi-Oh! We'll be playing that tomorrow. I initially thought that it was time to climb rank once again. But there's a new event happening, so we might play through the event first. I've been playing through the event little by little. I'll continue playing the event tomorrow. Okay, we'll do that tomorrow for Yu-Gi-Oh. Then yeah, this Saturday we won't have any streams unfortunately, so tomorrow is our last stream of the week. Next stream will be next week. All right. Okay. Random shout out. Let's random shout out one member of Moteki University. Who do we shout out? Who have I not shout outed yet? Shout it out. Who have I not shout outed yet in Moteki U? Let me check. Let's give a shout out to hmm 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 hmm. Maybe we can give a shout out to Kukushi. Shout out to Kukushi. Kukushi is another fantastic streamer. He let me do the shout exclamation point shout out Kukushi. I think this is how you spell Kukushi's name. Like this, right? I think it is correct. So random shout out to Kukushi. Right? Type the correct command. Ito ata. Ayan. There you go. Random shout out to Kukushi. Kukushi is one of the streamers in Moteki U. Actually came from Paul's server. I know him ever since I was part of Paul Poltergeist's server. So if you're looking for, I think they mostly stream nowadays more long-term multiplayer games like Zomboid, Project Zomboid, or 7 Days to Die or something like that. So if you're interested in that sort of shenanigans, go follow Kukushi and go follow as well all of my friends in Moteki U, my gen mates, Hal Sunaros, Kira Rin VT, who is actually also still streaming right now, and also Ren Mori. Go follow all of them. Go follow all of my friends also in Moteki U. They're all fantastic, amazing people, and they deserve more views, more followers, because I think they do work really hard. So go follow them. All right, that's it for today. I'm already quite tired. I'm already quite drained, but this was really fun. I enjoy these types of streams. If you want more of these types of streams, do let me know what other topics you'd like me to try and teach. Right? If there's something you're having difficulty with in your classes and you want me to take a stab at teaching you, then yeah, why not? We can do that. All right. Thank you everyone for tuning in tonight. I do appreciate all of you. I do hope that you will become better and better versions of yourselves. I hope that next time we see each other again, you will be even more fantastic and you will be shining brighter than you ever have. Thank you to the new followers. Thank you, Lil Ann. Thank you, Joseph Waffle VT. Thank you, Azurin. And thank you, Oshu. And thank you once again, Azurin, for the raid a while ago. All right, though. Let me just drop some follows. I might forget. Just drop some follows. Follow. There you go. Okay. I'll see you all again tomorrow. Like I always say, mo take care of the environment, mo take care of each other, and mo take care of yourselves. Sayonara, everyone. Otsu Sensay. Bye. Wait, don't leave yet. I'm still setting up the raid. I joined at the last minute. No! Aki7, we're about to raid. I'll be streaming again tomorrow at 8 p.m. 8 p.m.-ish. I'll be playing Yu-Gi-Oh! So if you wanna watch me play Yu-Gi-Oh! I'll be streaming again tomorrow. We're still raiding Rena Fenrir. This is our raid message. We just had our calculus class. Rena Fenrir. They're playing Goose Goose Duck. Go show our support to our friends. Bye. Let's raid. Let's go raid out. Let us watch our friends stream. We had fun today, so we want them to also have fun. That doesn't work. I'm tired. Can you tell that I'm tired? Can you tell that I can't think anymore? Can you tell that my brain is dead? I want to eat. I'm hungry. I should get some food. Bye-bye. Take care of yourselves. Bye-bye.